programmers! This is a video about the different storage classes for your variables in C programs. So we've talked about in other videos how variables have a scope and a lifetime. The variables will stick around for a certain amount of time before that memory is released. And there are 4 different storage classes: auto, static, extern, and register. Well, almost all of the examples I've shown so far have been the storage class auto, which is short for automatic storage. Automatic storage is automatically reserved when the function begins and it's released when the function ends. So in this little example fun, I've got 3 variables A, B, and C. All 3 variables are using automatic storage you could say auto for short. So even though I didn't put it here, I have a little comment saying by saying int a is equal to 0, that is exactly the same thing as saying auto int a is equal to 0. So what might be new for you with this video is static. So static is different than auto. So with auto, when your variable storage is released at the end of the function, the lifetime, let me go back to auto. The lifetime of this variable A, it's allocated when you start the function and it's released when you get to the ending curly brace at the end of the function. Not so with static. If you have a static local variable, so this variable b, which is inside of a function, but with static, that variable is going to keep its value in between function calls. That memory allocated for a static variable will stick around in between calls to the function. So let's look at what would happen with this function. My variable a is automatic storage. So every time I start the function, it's going to reinitialize this variable to 0, add 1 because of the plus plus, and then print a is equal to 1. Every time I call this function, if I call it once or 100 times, it will always say a is equal to 1. But b, on the other hand, the memory is allocated once and sticks around. So that b is equal to 0 part does not happen every time you call the function. It only happens once. And then every time you call the function, you're going to add 1 to b. So your first print statement will say b is 1. The next one, b is 2, b is 3. And I don't want you to take my word for it. Go ahead and type up this little example. I catted this example where I have my fun function with 1 automatic storage variable A and 1 static storage B. And you'll notice that when you run fun in main, so let me make sure that I can compile and run this, and we'll see that, oops, let me get back my compile line and run it, we're going to see that every time I print A, it's always 1, but B is going up by 1 each time I call that. So we can see that that variable B, the memory is sticking around, and that's what the static does for us. Okay, now it's going to seem like I'm going on a tangent, but it will tie back into our storage classes soon. Let's talk a little bit about local versus global variables. So global variables are any variables that you've got your declaration statement outside of any function. So in this little example in the green box, I only have 1 function and its name is main, and the variable price1 is the declaration and the initialization. That's both outside of main. This would be a global variable. And then price2, that is just a local variable. We also found out that is also an auto variable or automatic storage. But let's think a little bit more about this price1 global variable. So I've got the example here where I just show that you can print price1 or price2. Those are both visible inside of main. And I never want you to take my word for it. I always like you to be able to copy and paste or type really quick an example where you're going to see your global variable and your local variable. And then I'll, of course, compile that with a GCC, and the name of my file was global.ex.c, and then we run it. Oops, sorry. I have to say get it from this directory. Okay, so global versus local. What if I have another file that has a function that I want to run? Can I run this function that's defined in a completely different file in my other program that has main in it. So let's see. And then I'm going to pull in the variables later. But first, is this possible? Let me get up a working code example and we can try it. So I created my file, I called it file2.c, and it just has a tiny little function with one print statement. And I want to see, can I call this function from another file in a main? So I'm just going to have the name of the function, the parentheses, and as is, this is not going to work very well. So you might wonder, what's the compile line look like? Here it doesn't know what function is. We actually, in another video, I talked about how you really should be including both of those .c files when you're, oh, sorry, the other name was file2. When you're compiling, you really should have both of those compiled, but there is still a problem with my function right here. When it's compiling main, it doesn't know what function is, and all we need to do is fix that is to include a prototype somewhere before we actually call the function. A lot of times this will be in a header file, but because I want to keep this simple, I'm just going to put it above main. Could also have put it in main. So now the same compile line should work, and so the answer is yes, you can call a function from a totally different file, and that's allowed. So now let's get back to what I was talking about with the variables, and this will tie into the storage class for the variables. So my next question is, we found out we can call a function that's in a different file. Can that function in the different file access the variables from our first file? So we had price1 and price2. Can the function in a completely different file access price1 and price2? And the answer is yes and no. For any local variables like price2, there is no way to access that from our other files. But there is some hope with a global variable. If I make a tiny little tweak to this program, I will be able to access that. And the tiny little tweak that ties into what the topic of this video is, which is the extern. So we want our global variable price1 to be defined and initialized as a global variable once, and the other file that wants to use that, it just needs to use the word extern and then the same variable name and the same data type, and then this will allow it to access that global variable that's actually declared in another file. So let's see a working code example. All right, now we've got our two files. The first file has that global variable price1 set to 10, and then the other file says extern, so this is externally defined, declared externally, so we want to be able to use price1, but you're going to find price1 somewhere else in a different file. We're going to compile with the same GCC line and then run it, and we're going to see that the first two print statements come from main, but the third print statement is because when we call function, that function prints price1, which is actually the price1 that we have in our first file. So pretty cool. We're getting pretty complex. That is extern, or externally declared variables. So it's different than our other declarations because when you see the word extern, it doesn't cause you to allocate memory for your new variable. It just means that variable already exists somewhere else in your program. And because it already exists and is initialized somewhere else in the program, you do not want to try to initialize it on the extern line. So this is just saying it exists somewhere else. All right, let me tie it back into what we were talking about with static. So what if your variable is global and you also put the word static at the beginning? So this is global, it's defined outside of any function, and I'm putting the word static. Well, in this case, it's going to prevent other files from being able to use that static global variable. So it's a little bit different than we saw static used before when it was a local variable. If it's a global static, it's going to prevent that variable price1 from being used inside of another file. So with our code example, I simply added one word static to my global variable. I tried the same compile line that worked so well last time and error. So because we put that static, then our other file can't use price1. All right, and we only had one more type of storage class, and I'm gonna really zoom past this one because the video is getting pretty long. So our last type of storage that we had mentioned existed was register, and if you use that in front of your declaration, you're saying that this should be stored in a register instead of the RAM. All right, happy programming.